Okay, so let's try 19.4 number 5. And just at first glance here, I'm a little worried. So I have a vector field. F of x, y, and z is minus ci plus xk. And I have a surface, which is a square pyramid with a height of 3 and a base on the xy plane with a side length of 1. Okay. And then they tell me that I'm supposed to compute the flux 2 different ways, directly and using the divergence theorem. And in each case, they tell me the surface is closed and oriented outward. Okay?
It's not a pyramid, it's an obelisk.
Okay, so
I'm joking.
yeah.
I have 3.
I'm super done classifying pyramids. So a pyramid looks more or less like this.
Yep.
This is the traditional square-based pyramid, as opposed to the variety of other pyramids and lazy cones.
That's what they have in Egypt, and they're called pyramids, and they're square-based.
This is true. They are, in fact, I think, square-based, although it's hard to tell from the pictures.
I've been there.
That's hard.
You've been there?
I've been there.
Cool. How big is this space?
Huge. Like, you just feel like an ant.
Like, how tall is it actually?
I was there when I was like 10, so
Okay, so everything is huge.
everything.
Also, you're still small, so everything's still I feel this way sometimes. I walk into like buildings like this one, I'm like, wow, the ceilings are really nice and tall in here. But in undergrad, I had a professor who was 6'10", and I'm sure he felt otherwise about every ceiling. So,
Like that.
yeah, he hit his head on like standard door frames. It felt
Yep.
really bad, dude.
I have,
Duck.
I think my friend's brother is
Okay.
6'6".
Anyway, point is, this is a square-based pyramid, and they tell me that the base is on the xy plane and has a side length of 1. And I'm gonna go out on a limb and assume they mean that, like, what's my complaint about this problem?
It's not oriented on the plane at all.
Yeah, like, where the hell is this thing?
Well, yeah, compared to the Z-plane.
You guys see that? Like, they didn't tell me where it was at all. So, like, I don't know coordinates for any of these points other than that that these are in the xy plane somewhere.
Yeah.
So it could be in the negative Z or the positive.
Can you just
We assume Z.
Yeah, I also don't even. So I'm gonna.
Oh, we don't
In my picture here, I kind of assumed that these triangles were all the same size. That's not I mean, I'm assuming that's part of the definition of the word pyramid, but
How can you make a
And
difference?
also,
It
we're
could be-
assuming
it
it's
could be
upward
slanted.
oriented.
yeah, it could be like a slant pyramid, but.
Oh, man.
It could be.
But anyway, hopefully this will come out in the
Oh,
wash.
okay.
So how would I check to see if this is going to come out in the wash?
Do it the easy way first. Do the divergence.
Yeah, let me just look at the divergence, right? So like I'm trying to calculate the flux through S of this thing, right? So I need the flux through S of F dotted with D area, right? Okay, and then you apply the divergence theorem, right? Okay, so you get a triple integral of the divergence of F. And really, I'm doing this crappy notation thing again, right?
Yep.
So here, keep in mind, S is the surface of the pyramid. So maybe I just write that here. Surface of pyramid. And over here, I'd write inside of pyramid. You guys with me on that? Okay, so what's the divergence of F? Maybe that'll make all of this nonsense about coordinates make sense. Yeah, so, oh, weird. So this looks like a two-dimensional vector field, right?
Well, because
Where's the
all of
other
the
one?
values are
Well,
zero.
so does that mean that this vector field doesn't intersect the?
So that's minus c comma 0 comma x, right? And then when I take the divergence of that, I'm taking the partial with respect to x of z, which is 0. The partial with respect to y of 0 is 0. And the partial with respect to or with respect to z of 0,
Which is 0.
of x is 0. So I got a big fat 0 out of the divergence theorem, right? Because this whole object is 0. Is that 0 a vector or scalar?
Scalar. Oh,
Be zero
yeah, it's a scalar because you dot it.
It's a scalar because I dotted it,
Divergence.
right? Which means the divergence is this, and normally this would be a scalar function, right?
Yeah.
So this is the scalar function 0 here. And you're adding this up over the inside of the pyramid.
So if it fails the divergence, it's no dice for the whole thing. Like you can't do the long method for this even.
Oh, I still can. Yeah, you can still do the long method for this. So this isn't a fail. This is just an easy eval. Right, so the divergence was 0. So what's the integral over 0 of?
Of anything, basically.
Yeah, over, right, I'm integrating 0 over the pyramid.
0.
So if there's no mass in the pyramid, the total weight is 0, right? Okay, so I got 0. Cool. What that means is there's no flux through this thing, according to the divergence theorem, right? To do this the long way, I need to assume some stuff. Because to do this the long way, I need to parameterize this pyramid. You guys with me on that? To do that, I need to,
You need to know where it is, right?
yeah, I need to know where the hell the thing is, right? So you could run through this the long way by saying, okay, like, pick some axes. It's not going to matter, right? And that's the only reason I'm saying you could pick some stuff. But they didn't actually give you enough information to do this the long way.
Yeah, we can even do this if we wanted to, huh? Because the field changes over here. It's not.
Yeah, so what's going on, right, is that this vector field, right, flows net 0 through this surface. So probably what that means is that vectors, oh, we can figure this out. Vectors flow none front and back, right?
Yeah.
And then there's some x and z component, right?
Oh, so that'd be like saying it's blowing through an edge on the xc plane, and there's no flow, or there's no flux in an edge, right? It doesn't have a y component. You just be blowing parallel to the plane.
Yeah, so I'm blowing parallel to a plane. That might be, right? And I think this thing is basically rotation. You guys see that? So what I'm seeing is that this thing takes x and z, right? Interchanges their roles and slaps a minus sign on one. That's that vector field that makes spinning around the origin, right? This spinning around the origin happens in the, yeah, this kind of happens around the y-axis, right? So this is just, there's like my y-axis here. Where's my ear? So there's like my y-axis here, right? And there's just spinning going on this way. You guys see that? Wherever your pyramid is, like whatever's going on with that thing, it's a closed shape, right? And we're spinning in from this side and then out through the other. You guys see that? This thing isn't tending to compress at all, it's just rotating. And so anything that goes in the bottom is going to be counteracted by something coming out the top. And that's really what you would find if you parameterize this thing. You'd see that into the bottom plane there's some stuff coming, right? You're getting some net flux through the bottom. But up through these sides, right? And probably you're getting a little net flux through this side too. I don't know, it depends on the magnitude of your spin and how eccentric your pyramid is. This being 3 tall and 1 square, I think it's probably tall enough to get a little flux in on that side. But, whatever. You're going to find that the fluxes through these sides match the fluxes through that side with opposite sign. Oh, and the other one, you're going to lose a little bit through the other one too, the back face there. You guys see that? That said, I don't have the tools about this pyramid. Like, I need more stuff to be able to parameterize this thing. If they told me, like, instead of the base is on the xy plane, if they had said the base is 0, 1 cross 0, 1, right? And if instead of it's a square pyramid with height of 3, if they told me the height of 3 is over the point 1/2, comma 1/2, right? Like now I've got enough stuff. You guys see that? Like I can parameterize the base, and then each of the 4 faces is a plane, and like this one, for instance, this right-hand side, that goes through the point like 1, 0, 1, 1, and oops, need my Z's. So in the XY plane, it goes through 1, 0, 0, and 1, 1, 0. And then this peak is at 1/2, 1/2, 3. And you could use those 3 points, make yourself the equation of a plane, right? Well, don't do this.
So even with orientation, though, you could use the divergence method, right? It would still fail.
Even with,
Because it's still Zi, xk. Even if you know where the pyramid is, that first step will work.
oh, so even if I know where the pyramid is, this is, again, not working. This is working, and I'm getting an answer. So the net flux is 0. That is my answer. And if I parameterize this, I would spend a long time chasing it around,
You'd still get 0?
but I would still get 0.
Okay.
A little optimistic.
You guys see that? Cool. That would take forever, by the way.
But then wouldn't the long way also tell you what size would necessarily...
Yeah, in the long way, you could get some bits and bobs that would help, right? Like, you could see that the bottom, for instance, is getting a net flux in, and the tops are, like, losing. And then we could answer this question about whether the right-hand side is gaining or losing, depending. I suspect that it's gaining, but that's just a geometric intuition, not an answer, right?
So like if you wanted to like find the flux for that without the bottom, you could just do the divergence and then find the flux at the bottom and subtract it, right? It's like a alcohol.
Yeah, so what I know, right, is that at the very least, the flux through the bottom matches the flux through the 4 other sides put together with opposite sign, right? But that's really just me saying, like, this guy, right, my flux through the surface is the flux through the top plus the flux through the bottom. You guys see that? That doesn't tell me which of these is positive and negative, it just tells me that they canceled. Or that one of them was 0 and the other one was also 0. You guys see that? Like, I didn't actually learn a ton here from the divergence theorem, I just learned that the net flux is 0. It doesn't tell me much about the individual bits and bobs. I don't know which of those sides canceled with what. Like, this could be 0, and the flux through the top could have 2 sides that cancel and 2 sides that are 0. Or it could be 3 sides that are weird and 1 side that just happens to cancel those 3. Which is kind of what I think is happening, but you guys all good? Like, yeah. Don't try to chase down the individual sides out of something with a bunch.